Yeah.
So I know it's a little different, but I thought if there ever was a good time to make your notes like this, this is today's the day. And the reason is because we're going to be graphing for a couple of days. And we're not in our graphing unit anymore. Okay, today officially marks the start of Unit 4. It should take about 3 weeks to get through the whole unit. So I know that Unit 3 is all about graphs and lines and stuff. And you say, well, gosh, I thought we were done. But what you're going to learn about in the next few weeks is how to solve what we call a system of equations. And we're doing this in Algebra 2, except we're doing it with three variable equations, which aren't straight lines, they're planes. So in Algebra 2 right now, we're studying where flat surfaces cross in space. What we're going to study in Algebra 1 is where lines cross in a plane. So what you're going to see throughout the next 15 or 20 minutes is when we graph lines, there are things that happen. Can you guys off the top of your head, it's always an odd question. You know, I do this every year and one of the three is very hard for people to come up with. So here it goes. If I'm a student and I graph two lines on the same graph, what's one thing that could happen?
It could be parallel.
They could be parallel. I was not expecting that to be the first answer, but I'll take it. And if two lines are parallel, when will they cross? Where?
Yeah.
Correct. So one type of system that we're going to see in this assignment and for the next few weeks is a system that actually has no solution. The solution of a system is the magic point where they cross each other. And like Keith said, if they're parallel and they never cross, well, then there's no solution. And so we'll see that visually today. If I graph two lines and they never cross, then we'll say, well, there is no solution. So that's what I'll say. What's another possibility? Yeah, and honestly, that's a little bit too specific, but you're right. They could be. But more generally, do we agree that more often than not, they're just going to cross?
Yeah.
Like it's a pretty special thing to have two lines that don't cross. For two lines to be parallel, that's a big deal. And if one line has a slope of up 5, right 2, and one line has a slope of up 5, right 3, they're going to cross eventually. It might take a while to find it, but they will, right? So that's another possibility. So far we've talked about two lines could be parallel, meaning they never cross, or two lines could cross. And if they cross at a right angle and they're perpendicular, it's honestly not really that interesting at this point. But what's important is that they cross. And the third one is always the odd one. What's another thing that if I graph, if I give Josh an equation, and then I give Hannah an equation, and I have them graph it, and then I lay their graphs over each other, like on wax paper. What's another thing that could happen?
They could be the exact same.
Yeah, again, you're coming up with good ones today. You're on a roll, buddy. Did you have some coffee today or something?
Yeah, I drink 4 cups of coffee.
And I think waking up at 4 a.m. is good for you, but two lines can actually sit right on top of each other, which I know might seem abstract to you, but what happens a lot of times is you might look at two equations and say they don't look like the same equation, but lo and behold, they actually are. And so those are quite literally the only three things that can happen if you graph two lines in the same flat plane. They are either parallel, meaning they never cross, no solution, or they cross, meaning there is a unique solution point where they cross, or they just literally are the same line, meaning that they have infinite solutions. A solution of a system is the point where the lines cross. And if they're always sitting on top of each other, they're always technically crossing, which sounds weird. Are you with me?
Yes.
So after the next couple days, we're only going to spend a couple days on graphing, and then we're going to get into what are called the algebraic methods for solving systems, substitution and elimination. And unless you're pretty weird, you'll like those better. Most people graphing is kind of a drag. Um, yeah, I'm one of those people that doesn't like graphing very much, but I have to embrace it to some extent, based on what I do for a living. So, but I like algebraic stuff more. I like just tinkering around with X's and Y's and numbers and stuff like that. So let's get to it. So I don't know how many of these we'll get through. I have 8 of them in the queue and ready to go. So what we're going to do is we're going to graph lines and we're going to see where they cross. So let's put our Unit 3 mad skills to use here. Not that your goal is to make me proud, but I'll say it anyways. Make me proud. How do you graph that first equation, y equals -1? Good job. So you put your point at -1. Thank you for saying on the y-axis. That's huge. And then what kind of line are we going to graph?
A horizontal line.
Good job. So we're all going to take our rulers and we're going to graph a horizontal line, y equals -1. We know from the hundreds of times we've talked about it that an equation with only a y is horizontal. There's no x to give it any play up to uphill, downhill tilt. Okay, I'm going to switch colors. I know you don't have that probably with your pencils, but I'm going to switch colors just since I'm recording this and I want it to make sense. Let's graph the second line. Where would I start that graph at?
+2 on the y-axis.
Good job. So I'm going to go to +2 on the y-axis, also known as just go up 2. And now from that home base, I have to embrace the slope. What does the slope of 3/2 mean?
Up 3, right 2.
Up 3 and to the right 2. But you know, I'm not going to go into some long side note about this. I should someday show you why I care. Graphing 2 points is not enough. Okay, I want you to graph, I've said this before, as many points as the graph paper will allow. And I will show you, I promise. I'm actually going to photocopy one of your district assessments. I don't remember what class it is. There were 2 people who felt the burn as to what happens when you just graph 2 points. So I'll show you. But for now, just please do as you're told. We're gonna go up 3, right 2, but then we're gonna run out of room. So we're gonna double back and go down 3
Left.
and back to the left 2, and then down 3 and back to the left 2. Okay. And then we are going to, despite our desire to just say what the answer to the problem is, which I get it, we can already see it. We are going to graph the other line. We already know the answer to the problem, by the way, because we can see where the lines cross. So do your due diligence, make sure you get both lines graphed like this. Now, all we're doing is simply making an observation. It's a very simple observation. Where do the lines cross? Well, you don't need a math degree to see that they cross right there, correct? So my only job now is to name that point. And what's his name? -2.
-1.
-1. Make sure you write it like that because it is a point. So points need parentheses and commas. It's an ordered pair.
No.
For now. Yes. What made that problem so easy? And if you want hint, turn your paper over and look at number 5. And I don't want to do this yet. I want to do one more because I think I have a little bit of time. I don't know how much, but do you see what changes when we get to the backside?
Yeah.
What changes?
Y has number.
You got to do the math first, right? You got to solve the equation first. You got to get y equals mx plus b. So we're going to kind of enjoy the ride here on the front page we'll do one more together. And then, I don't know, let me take a look over. I'm going to pause this real quick. Oh, you already know. Thank you. God, that was useful. So we get out at 44. So we've got a little bit of time. So let's head over to problem number 2. And let's graph the lines. So again, I'll color code them for you. So let's do red line first. Where does he begin?
-4 on the y-axis.
So down 4. And what's his slope?
Down 3, right 4.
Right.
Left 4.
Down and right for sure. If you go down and left, those negative motions are going to cancel and the line's going to go uphill. You don't want to do that. So we want the line to look like this, right? It's negative. So we're going to make it look like that. And since I don't have enough room to go down and right, then I'll just go, oh, I know, up and left. So I'm going to go up 1, 2, 3 and back to the left 1, 2, 3, 4. And this is a case where I honestly can't do any more points because the graph simply will not allow that. There's not enough space. Okay, so we put arrows on both sides. And then let's graph the other line. And if you're thinking, why are we wasting our time? You're not being disrespectful if you wanted to ask a question like, why are we even graphing these? Because some of you already knew what was going to happen before we started. Am I right? Yeah. So we sometimes start to say, wait a second, I see what's coming. This next line, again, I'll switch colors. We're going to start by going up 2. And what's his slope?
Down 3, left 4.
Down 3. You quit
Right
doing,
4, right
yeah.
4.
Yeah, down 3 and right 4. Or as Nash said from the back of the room, the same as the other guy, right? And this one, I actually have enough room to do a couple. So I'm going to go up 3 and then back to the left 4. I'm always going to graph as many points as I can. You should too. Okay, and when I graph those 2 lines, and you might have missed it at first because, it's early in the lesson and you're like, why would I look for that? But in hindsight, you realize, oh boy, wait a second. Look at what we got.
Parallel lines.
We have parallel lines, and we probably should have known it from the beginning, right? Because if they're already in y equals mx plus b and their m's are the same, then you know they're going to be parallel lines. So what would we say is the solution of this system? There is no solution. And you just spell that out. You just write it out. You write out no solution. That just means that there is no point ever that would be on both of these lines at the same time. It is impossible to be on them both. Good so far? Okay, let's flip this over and look at the backside. I didn't figure we'd have time for 8, but maybe we can get like 2 more done. That'd be pretty rad. So how about this? I'll let you guys pick and choose. All of them on the back I made, so you have to do math first. So what would you pick? Which ones would you like to do?
5.
5 is fine. So let's do number 5 first. Why not? It's the first one on there. So let's do the top equation. And let's all agree and understand that that is no bueno, right? Like it's not ready for graphage. What do we have to do?
We have to give X a number.
You better stick that 4 over to the other side. That -4 is like, hey, dude, you're like not where you're supposed to be. So we're going to add the 4 across to this side, giving us a final graphable equation of y equals what?
4x
plus 4.
X plus 4. Yeah, we would only put 4x if we were multiplying by 4. And we're adding. So that line is ready to graph. You have a choice at this point. You can graph it and then come back. I like to do all my math first. So since I'm the guy with the fake pen, we'll do it my way. But when you're working alone, you can graph and come back. I'm going to just do all the math. So let's talk about Mr. Purple here. Give me a good strategy as to how I could go about getting y by itself.
Add 3 to.
Yeah, listen, I got to be honest. If you move the X, I've got no issues with that. I'll just tell you as the guy who wants to give you good math habits, I would personally move the Y to that side, and then I would offset that by moving the 12 back across. You can do that in math. Once you get confident enough, you can just chuck things over like a juggler. Just throw things over the equal sign. You just have to remember never, ever, yeah, man.
You gotta make a negative.
Yeah, that's it. That's the only toll or fee you have to pay when you juggle things across an algebra is so easy once you get that. You want to move it on the left side? Move it. No one cares. Just make sure you change the sign. So when I bring the 3y by adding it to the other side, he becomes 3y. The negative 5x never had to move, right? He's like, I'm fine where I'm at. I'll watch you 2 idiots do your little cute dance and then let me know when you're done messing around, right? So the negative 5x is still negative, and then the 12 comes cruising across, and what's he become?
A negative 12.
A negative 12 or a -12. That's how I like to do math, is I like to just look for things I can do to improve the quality of my life. And now what do we do?
Mr. Ahern, wouldn't we divide 3y by 3 to get rid of?
We're going to divide everything by 3. So we're going to divide here, here, and here. Remember that when you do division, it's distributive. Division and multiplication hit everybody. So when we divide by 3, everybody gets affected by that. So we get y equals what?
Y equals -5/3 x minus 4.
Good job. That is solid. And that is why we do unit 3 before we do unit 4. So that conversations like this go well, like that. Good job.
Then don't we graph?
And now we're ready to graph. So let's talk about Mr. Red first. Where do we begin our graphing journey?
4 on the y-axis.
So up 4. Good. Keep it simple. Up 4. And what's his slope? Up 1, right 1, or conversely, down left, down left, down left, down left, down left. If you want to save time, just go down 5 and left 5. Like it's all going to come out in the wash. You do not want to graph lines when you just have 2 points close together. It is bad juju, bad practice. Okay, so I'm going to grab my ruler and I'm going to make a line through those points. And I missed the mark by just a little bit. I'm going to see if I can budge it. I don't know if it'll let me, but yeah, I like that a little better. So there's Mr. Red. How do we start the graph for Mr. Purple?
So since we can't go down 5,
Where do we start the graph?
-4 on the
Down
y-axis.
4. You guys do not like the words up and down. Okay, so down 4. And what is the slope of that line? Like Keith was about to say, we can't do what we want to do, right?
We cannot go down right and down 5, right 3,
So
because and so we can go up 5 and left 3.
That is correct. So I'm going to listen, I cannot get outwitted by algebra. I won't let it happen. You shouldn't either. If the slope says negative, you make your line go downhill. You are the boss. So like Keith said, if I don't have enough room to go down and right, that's okay. I'm just going to double back and go up and left. 1, 2, 3, 4, 5, 1, 2, 3. And that is all the room that I have. And again, despite your desire to just give the answer, we're not going to call this done until we've done our due diligence and actually physically graphed the lines. So I'm going to move this line, get it spaced a little better, and I like that. And finally, we can name the solution point. What is the point of crossing?
1, -3.
It is
-3,
negative
1.
3, positive 1. The only thing, you said we get out at 44, so don't quite pack yet. Give me 30 more seconds. I promise you'll be early. The only thing I'm not going to rush to get to today is what happens when we get infinitely many solutions. So we're going to do those 3 examples, and then we will resume this lesson right here on Monday. Deal?
Deal.
Okay, that's it.
Mr. Hand, would you say I did good on this?